All right, we're going to start with number 5 because we did the first few in class. So I would like to go ahead and, this is what it's going to look like when you see it on WebAssign. But I'm going to change this to a coordinate so it's a little bit easier to see. So I've got 0, 5, and I've got 2, 1/2. Okay? So looking at that, I need to find an exponential model of y equals a e to the bx, and y equals a e to the bx. Okay? So what we know so far is that this is an xy coordinate and this is an xy coordinate. Okay? So we are going to set this one up as 5 equals a times e to the b times 0. And we're going to set this one up as 1/2 equals a times e to the b times 2. And now what I can do is I can solve this one for a, because b times 0 is 0. So this gives me a e to the 0, which e to the 0 is 1, so I get 5 equals a. Okay, so if 5 equals a, I'm going to come over and I'm going to input that information into this. So I get 1/2 equals 5 e to the 2b. And now I can solve for b. So this goes back to what we were doing in class on Wednesday. I'm going to divide both sides by 5, so I get 1/10 equals e to the 2b. So remember, I already know what a is. Now I just need to know what b is. So I'm going to take the natural log of both sides. And that allows me to drop this down as a coefficient. So I've got the natural log of 1/10 equals 2b times the natural log of e. The natural log of e is 1, so I'm going to divide both sides by 2. And now I know what b is. So the natural log of 1/10, sorry, I'm doing this on the side. The natural log of 1/10 divided by 2 gives me negative 1.151. And that's what b is. So my new equation, y equals a times e to the bx, your y and your x are going to stay as variables. So this gives me y equals a, which is 5, times e to the negative 1.151x. And that is your equation that you need for number 5. You're going to use that exact same process for number 6, but I'm going to go ahead and set one up for you. So for number 6, it says that we've got Australia in 2013 corresponds, t equals 13 corresponds to 2013, so t equals 0 must correspond with 2000. So what I have is 2 points. In the year 2013, Australia had 22.3 million people. In 2025, which is year 25, Australia had 25.1 million people. So now I know 2 points, and I can set that up as y equals a times e to the bx, y equals a times e to the bx. See if that's a little bit easier. I'll turn the little lamp off. That's a little bit easier to see. Okay, so y is going to be 22.3 equals a e to the b times 13. And then 25.1 equals a e to the b times 25. So once again, I'm going to solve for A. It's going to be kind of ugly, but I'm going to solve for A. So I'm going to divide both sides by e to the 13b. So I get 22.3 over e to the 13b equals A. So it's not as pretty as it was last time, but the process is still the same. So I'm going to take this information and put it into here. So I've got 25.1 equals A, which is 22.3 over e to the 13b times e to the 25b. Okay? These reduce. They've got the same base. So what do I do if I'm dividing with the same base? I subtract my exponents. So I've got 25.1 is 22.3 e to the 12b. Okay? And then divide both sides by 22.3. So I get 25.1 divided by 22.3 gives me 112,556. 112,556. Use as many decimal places as you can. 0538. 0538 equals e to the 12b. And now we're back in familiar territory because I can take the natural log of both sides. Okay, so the natural log of 1.125560538 equals the natural log of e to the 12b. So it's ugly, but this is really just one number equals the natural log of e to the 12b. So I'm going to drop my 12b out front. So I've got the natural log of 1.125560538 equals 12b times the natural log of e. And what do we know about the natural log of e? It is 1. So I can divide both sides by 12. And that's going to give me what b is. So b is going to be the natural log of that divided by 12. And I get 0.009856. Which rounded would be 0.009. Okay, which you can't see. Sorry. There we go. Okay. So I'm going to use all of the decimal places until we're done figuring out what A is. So this is going to be my rounded form for the final answer. Okay. And so I've got 9856764. 9856764. Okay. So I'm going to take this value for B and I'm going to put it back in for A. So I'm going to figure out what this is up here. So 22.3 divided by e to the 13 times 0.0. I just missed a 0. My dog is whining in the background. Hang on one second. 98,56,764. 98,56,754. Okay. So now I've got 22.3 divided by e to the 13 times that answer. And I get 19.6. So my final exponential model is y equals A, which is 19.6, times e to the 0.0099 to the x. Okay, so that's how you're going to do the other ones. Make sure you can see that okay. That's how we're going to do the other ones. Okay. All right, so for number 7, what we have is P, or population, equals 4.2 e to the kt. And we are told that in 2008, the population was 8,000. Well, this is being measured in thousands. So our population needs to be 8. Okay? So I know that sounds weird, but we're given that it's 8,000 and we're measuring in thousands. So this is going to be an 8 instead of an 8,000. So we have 4.2 e to the k times 8. So I'm going to divide both sides by 4.2. So 8 divided by 4.2 is 1.9047. 1.9047. Where'd it go? 61905. 61905 equals e to the 8k. We're trying to find out what k is, so I'm going to take the natural log of both sides. Okay, I'm going to drop my 8k out front. And what is the natural log of e equal to? It is equal to 1. So I'm going to divide both sides by 8. And that's going to give me an answer of 0.0805. So if that's what k is, I can use that information to come back up here and finish out this exponential model. So it is p equals 4.2 e to the k, which is 0.0805 times t. And we're supposed to figure out what is the population in 2018. So I've got p equals 4.2 e to the 0.0805 times 18. And I get p equals, hold one moment, 4.2 times e to the answer times 18. And I get 17,901. Actually, my rounding is off. Hang on. 4.2 e to the 0.0805 times 18 gives me 17,887. And remember that that's in thousands, so you probably got 17.887. We'll multiply that times 1,000. So we have 17,887 people. Okay, so I'm going to take off the last couple of problems. So really you've only got 7 problems to do in this section. And that is it.